Okay, so with both of these, you will often see an exam shown with a graph. Okay, so you have time along this axis, and you have mass on this axis. And you start off with your soil sample weighing about this much. Okay, and you keep weighing it, and it stays around the same mass because you've got it in a sealed bag, so it's not going to lose anything. You then start to heat it, and over our first heating period, we lose mass until it reaches a constant mass. And then you're going to increase the temperature again to like 350 degrees centigrade or something, and our mass will again decrease and then remain constant. Okay, so in our first period at the end of this, where it's remaining constant after our first heating period, this difference in masses is the mass of water. Okay, and then over here, this after the second heating period, this is the mass of organic content or matter, sorry, that we've oxidized, we burnt off by doing this process. Okay, so this is our first heat at 100 degrees centigrade, and over here we've got our second heat at, let's say, 350 degrees C. Okay, and that's oxidizing our or combusting our organic matter. Okay, so the last two parameters that we're going to look in our soil analysis is soil bulk density, which is a simple way of saying the mass of dry soil per unit volume, okay, in situ. All right, so we use the auger to give us a known volume, okay, because it's a fixed cross section, and we push it into a known depth. Okay, and then we follow the procedure above to work out our dry soil mass after heating at 100 degrees C. Okay, so that's a really nice and easy one. Now, soil pH, there's a number of different ways we can do this. Okay, we can use colors with a colorimetric chart to show us pH. Okay, so this is universal indicator papers or universal indicator solution, and both of these are called colorimetry. Okay, so we use a universal indicator solution. To do this, we need to get rid of the soil particles to help them settle from a sample of water. Okay, so we put soil into a test tube of a known volume. So here's our test tube. Put soil in, and then we add, so there's our soil, we add some water to it of a known volume. Okay, we also will typically add something like barium sulfate, which helps settle the particles so they are not getting in the way of seeing the color change. All right, the water is distilled water, so we are not contaminating our sample. We then add our universal indicator. Universal indicator is added to it. We shake it for 15 minutes. And then we compare color to chart. Okay, the process using like indicator papers is very similar, but instead of adding our universal indicator into the water, we dip the indicator paper into it, and then we compare it to a color chart as well. Okay, so much in the same way. Now, the limitation to this is this part here. Okay, this results in our limitation because comparison between the color that we see and a color chart is subjective. So it's possible that two different people will interpret it in different ways. Okay, we can improve on this by using electronic pH meters. Okay, so the pH meter should be calibrated using a known sample. So this is really important. It's always calibrated first. And then you need to wait until you have a stable or constant reading, which might take a little bit of time. And it should be placed at a standard depth within your sample. So you'd prepare a sample in the same way as you have done for the others. But once you've done that, you just use the electronic pH meter. Okay, and this is our sort of potentially our limitation to this, so it's less convenient because we have to calibrate it first using buffer solutions, which can be a little bit fiddly and expensive. Okay, thank you very much.